So, an ion is, yes, either a charged atom, or we can have a group of atoms that are bound together that have a charge. They're not neutral. So, name me one of the kinds of charges we can see, Haley. Positive. What's the other kind, Leanne? Negative. What do we know about opposite charges? Just with your hands, show me. Do they attract or repel? I'm sorry. Opposite charges will repel one another. Oh. Good, you're all on your toes. That's awesome. They attract. I haven't finished my cup of coffee this morning. Opposite charges will attract one another. Like charges will repel one another. Okay. Good. Good. See, I'm just seeing you're on your toes. So we can get a group of things that are positively charged and a group of things that are negatively charged. And they will be so powerfully attracted that they will sit side by side and actually form a compound. That's an ionic bond. So what you have is positive ions, negative ions, sitting side by side, and they are so powerfully attracted by their opposite charges that they actually form a compound, such as our old friend salt here, sodium chloride. There's a nice chunk of salt from the mines up under Lake Erie. I get these out every now and then. And this is just a collection of positive and negative ions sitting side by side. The force, you can pass it around. The force of attraction between those positive and negative ions, and I'm resisting the urge to lick my fingers because of all the salt on them, is sufficient to make that mass of salt. And there's actually about a, 50-foot thick, mile, 15, 20 mile by 100 mile chunk of salt under Lake Erie that they're mining. And that's all just because of positive and negative ions sitting side by side, forming a solid. The other kind of bonding that we talk about is covalent bonding. These are the two main types we're going to talk about first. In covalent bonding, we have atoms that are sharing. So in an ionic bond, we've got ions, atoms that have given up or gained electrons. We talked a little bit about ion formation in the last chapter. In covalent bonding, nobody has to give up an electron. They're going to share. So, let's see, your high school chemistry, 2 years of college chemistry, teaching chemistry, and I got to the point where I was teaching chemistry, and I still would forget which was which is ridiculous. The mnemonic that I use, has anybody here ever been on a team, been in a team sport? A few of you have, I think. Okay. Nope? Okay. Well, sometimes in team sports we have captains. You have team captains. Sometimes you have two captains who share responsibility. What is it called when you have two captains? They are what? They are co-captains. Co-captains are sharing responsibility. In covalent bonding, we have atoms that are sharing valence electrons. They are co-captains of the valence electron team, which is a nice little mnemonic. Versus ionic bonding, where we actually have ions, things that have given up or gained electrons. Okay. However, talking about covalent bonding, yes, ma'am. Okay. Yes.
Ionic bonding is just bonding of ions?
Yeah, that's all it is.
And covalent is regular ions?
Covalent, yes. So in an ionic bond, what you have are two atoms that have actually given up some electrons or gained some electrons, so they formed ions. That makes them so attracted to one another they're set shoulder to shoulder. In a covalent bond, neither atom is really charged. And we're going to talk a little bit about partial charge. But they're essentially still neutral atoms because they're sharing electrons to get to that octet, to get to the full S&P. So each of them technically has the same number of protons as electrons. Sometimes we have regions of overall charge, and we're going to talk about that in a second. So yeah. Okay. If you've ever shared responsibility with somebody, maybe with a sibling, maybe with a co-captain, is it usually really, truly equal? No. So you may be equally responsible with your sibling for making sure that dog gets walked and the garbage gets out and the rabbit gets fed. I don't know what your responsibilities are at home. In general, that sharing isn't always equal. So when we look at covalent bonding, which is bonding where atoms are sharing electrons, very often that sharing is not equal. So what we really start to look at is the idea that we have simplified this up till now. So in physical science, you talked about ionic bonds, covalent bonds, nothing in between. The truth of the matter is, very few bonds, that's like saying everything's either black or white. Very few bonds are all black or all white. So there's sort of a spectrum. Do you remember, let's see, what did we share? Raisin bread? Okay. So we said we could share a loaf of raisin bread. I hate raisins. I think they're disgusting. If Colton and I are sharing a loaf of raisin bread, he can really have it all, because I don't want any of it. Yeah. Oh, was it zucchini bread? Then I was sharing it pretty strongly, because I really like zucchini bread. Okay. How close to purely ionic or purely covalent a bond is going to come down to how strongly each atom likes its electrons. Remember the term for how fairly they share? Electronegativity, and I think it's actually on the slide right now, but that's okay. That's good, because some of you read it and went electronegativity, and some of you forgot that it was up there, so that's fine. Yeah. If we have one atom that likes electrons a whole lot more, it's going to pull the electron cloud closer to it. Okay? So, if we look at all of the potential atoms that could form bonds, do you remember what the most electronegative atom there is?
Fluorine.
We said, yeah, fluorine. Fluorine is the biggest electron hog on the planet. It sucks up electrons, it loves electrons. So, fluorine is, and this is sort of arbitrary, it's assigned an electronegativity value of 4.0. And I think on 151 in your book there's a periodic table that has electronegativity values. We'll use that extensively later. The least electronegative thing we've got is a 0.7. So the biggest difference that we can have between two elements is 3.3. Okay? That's the maximum difference. And I'm going to actually, oops. That'll make for an interesting little video. We'll touch.
Jump scared.
Here, we'll pause it right there while I grab a marker.